Okay, we are towards the end of the course and I would like to give you a summary of the coverage of what we did so far. We started off with an introduction to the course, a discussion of how inspired by the human brain we can evolve AI based models and algorithms towards these. So, we discussed models of a neuron, the mathematical model, and also we can enhance these models towards biophysical models, realistic biophysical models. We discussed neural communication, neural networks as directed graphs, and how we can evolve neural network architectures both feed forward and feedback based depending upon our learning mechanisms and knowledge representation. Then we discussed learning processes, learning tasks, right, which is supervised, unsupervised, and then reinforcement learning. Then we started off with the basics of perceptron, discussed both online learning and batch learning, and we discussed the convergence proofs of the algorithms. Then we discussed regression topics. We looked into modeling through regression where we covered both linear and logistic regression for multiple classes. Then we moved on to the multilayer perceptron, derived the backpropagation algorithm from first principles, and then looked into this problem which is the XOR problem, and then we discussed how this can be solved using the multilayer perceptron, which in this case used a single layer of hidden neurons as against what we could not do using a simple perceptron. And then we discussed the role of Hessian in online learning along with annealing and optimal control of the learning rate. We moved on to approximation of functions, ideas towards cross validation, network pruning and complexity regularization, leading to notions of convolution networks. Proceeding further, we discussed Cover's theorem. This is a very important result that leads towards pattern separability, and then we discussed the interpolation problem that led to the RBF networks, or radial basis function networks, and we also discussed the kernel regression and relationship to RBFs. Then we discussed extensively the ideas behind support vector machines, constructing optimum hyperplanes for linear separability that in some sense maximizes the signal to noise ratio metric for the two class problem. Then we looked into extensions of this for design of kernel machines. We revisited the XOR problem, and that led us towards robustness considerations to the regression problem. So, continuing on with the SVMs, we looked into the representer theorem and related discussions which led us to the introduction to regularization theory. We discussed the conditions for well posedness, specifically Hadamard's condition for well posedness. We discussed Tikhonov regularization, evolved regularization networks using Green's functions. Basically we have these Green's networks, and we also discussed the generalized RBF networks. Proceeding further, because it was in tune with the sparsity constraints, we looked into the basics of L1 regularization, looked into algorithms and extensions, and towards the last set of topics we discussed the Hebbian based principal component analysis, kernel based PCA, kernel Hebbian algorithm, and then some qualitative discussion into deep auto encoders, stack denoising auto encoders, and along with a discussion along with the derivation of the convolution neural networks. So, it is an extensive coverage at the introductory graduate level course in neural networks and learning systems. So, I hope you have benefited from this. So, the key towards the course is basically your homeworks and programming exercises that will reinforce your understanding into the concepts. So, we are towards the end of the course, right. I sort of gave you a summary of the course coverage, but again what drives this course, right. One is from the research side, other is development or implementation side. So, let me touch upon both of these aspects when I talk about two facets of AI research. So, one of the applications could be to develop ideas towards synthesizing an artificial brain. I mean, this is really a grand challenge. This is where it started off in the 1950s when AI took its birth, right, in the Dartmouth conference in 1956. So, people discussed, this was the basic idea towards synthesizing the artificial brain, and today almost close to 70 years we are evolved in our tools in terms of algorithmics, circuits and systems, and possibly poised at the right step towards these grand challenges. So, this is one of the key research areas. Second would be neurocomputing engines through bio inspired cues and biophysical models. For example, I need an artificial retina or an engine which can replace the olfactory system, right. We cannot just think about a sensory system in itself, but we need to bring in neurocontrol towards these systems. So, therefore, I think this is a very interesting confluence of biology, mathematics, physics, computing and lot of these applied areas. Okay. And the second facet of this research, so first is bio inspired engineering, right, bio inspired neural networks or bio inspired artificial intelligence, etc. The second facet of this research is to develop AI algorithms that are not necessarily biophysical in nature, but they can be driven through plausible mathematical models and endowing these models with learning, right. We need to learn the parameters of the through data correlations and data driven statistics. So, the models themselves need not be biophysical in nature, they can be well rounded in terms of the mathematical construction, right, that is also part of AI research. So, one side is the biological side where you take cues from biology and build these systems that can be fed back into biology or possibly develop systems that are bio inspired. The second is you develop algorithms or AI based algorithms specifically which are well founded in terms of their mathematical foundations that can lend themselves into algorithms for applications into real life applications. Okay, this is the other side of research. So, hopefully this introductory graduate level course will provide the foundations towards both of these as you explore the topics. So, towards the last, I would like to briefly touch upon ethics related to AI research and its implications to society, right, and whatever we do in science will have in some sense a bearing on the society we live in. So, AI based ideas are very powerful and literally everything can be learned from data correlations. This is very important because today we live in the age of data, and computing, communication, control, these are the three important ingredients in information and communication technologies. And now we bring in data and literally everything can be learned from data correlations, right. I am surfing the web and depending upon my surf pattern something can be implied from that, some decision can be made from that. So, it is a very powerful thing to basically looking through data from an individual or from a group or wherever it is to infer certain things. With this comes issues of biases, security and data privacy of an individual. So, therefore, when we think about policies, public policies driven by statistics and with having the AI umbrella on top of it, we should be very careful to not really give too much importance to biases. There could be biases because of statistical because of statistics, right. It is basically the mean of a population, but that does not imply that an individual is that. Similarly, data and security privacy can be very important tasks, because we do not want this data to be leaked to people or bots that ought not to get this data, and individual data privacy has to be respected. Now, when we think about weapons of mass destruction etc., that are very detrimental to life on earth, I think AI guided weapons of mass destruction can be very harmful to life on earth, and therefore, this is something that is very important when one thinks about research towards policies and regulations. Last but not the least, we are in the age of bots, and I think in 10 to 15 years this would be a reality that bots can be very much part of our system, right. From restaurants to corporate houses, we may see bots that supplement human population. While bots can supplement human efforts over mundane tasks, as well as offering a high level of expert advice into control and decision making, being a slave to bots can have serious repercussions. So, we agree that like humans that are possibly slow in control and decision making or computing, bots can be tremendously fast, right. We can process things in parallel, and we do in a parallel and distributed manner, but bots can do orders of magnitude faster computation that can lend itself to decision making etc. So, this is very important and useful for us, but we cannot become slaves to the decisions from these bots. I think this is an important takeaway advice. So, I think a few perils associated with these AI based I would say development or the evolution in our societal framework. So, these days people are talking about AI based game addictions, right, and teenagers and kids they get addicted towards these virtual games etc., and that is again being slave to these bots, and I think these should not be encouraged, or I think it should be done in a controlled way or a phased manner. One cannot become addicts to these AI based games. And then there is an increasing dependence of bots for routine household chores. I mean, we have bots that can mop, that can cook, and possibly even strike a dialogue with an individual over dinner etc. But I think we are sort of going away from how we lived in society, and this is an important thing, right. I think having an interesting conversation over a family dinner with humans, I think is much more worthwhile than possibly emoting with a bot as to how you spent your day and what you did etc., etc., or possibly cooking, right. I mean some routine tasks, of course bots can help us do this, but I think there is still a joy of doing things yourself, maybe watering the plant and let it plant grow. I mean, unless you are managing a huge yard or things like that which requires automation, but I think mundane tasks which I think humans have done and sort of which is pleasurable, I think those things cannot be replaced by bots. So, I think these are some implications I think that one needs to, I think this is not a general statement, I think this has to be custom made towards each individual. While you have the power of AI, while you have the power of using the bots, I think one cannot become increasingly a slave to these pots. With the completion of all the lectures, I would like to take a few minutes of your time to introduce the people behind this course. Of course, I am the instructor for this course, and I was ably assisted by my teaching assistants. So, all of whom are my PhD students. On my left is Amrita Machireddy, and the middle is Parayag Gaugi, and on my right is Zita Sashindran. All the TAs have taken a lot of care to look carefully through the video lectures, help in the editing process, as well as taking part in the homeworks and these details. Okay. So, I think I would like to acknowledge them as part of this work. Last but not the least, there is ground staff that have taken care towards recording all these videos and painstakingly being able to accommodate our schedules, and I will list their names. They are not here right now. It is Deepali Saloke, then Danaya Naidu, Avinash and Naveen. So, without whose help we would not be able to complete this journey in creating this MOOC course, which is whose effort is really 2 times the normal effort one can think of in a regular course. So, with this I would like to conclude this series of lectures. I hope you enjoy this. Please leave your likes and comments, and we will take a note of this, and above all I would like you to register to the course and then really learn through this experience. I wish you all the best.